Systems can be weaponized. They start to invent dangerously creative strategies to achieve their programmed objectives that cause a lot of harm. That it's the most concerning one, and that is the risk of loss of control.
That can detect sounds, recognize speech in multiple languages, and make
actually run some experiments to show at small scales behaviors that absolutely
There are a couple of different ways in which that could happen. I think it's useful, by the way, out the gate to highlight the positives too of this technology, right? It is, of course, a hugely beneficial class of technology. It's already enabled breakthroughs in fields as diverse as medicine and biology, material science, and so on. So it's important that we do focus on that at the same time as we consider the risks as well. But when it comes to the risks, yeah, so two categories of risk that we've been tracking, especially in the context of our most recent work with the State Department. So the first one is the risk that AI systems can be weaponized, right? These systems can be used deliberately to cause harm. There are a wide range of different ways in which that could be done. One that you could think about is AI systems that increasingly can write code better than human programmers can be used to write better malware than human programmers. That's a big risk class. And you can imagine a sort of new generation of autonomous malware agents. That's very much a possibility. In fact, at this point, kind of a likelihood. You can also imagine these systems leveraging their vast knowledge and understanding of areas like biology and chemistry to help with the design of new kinds of weapons, so biological weapons and so on. But the second category of risk, in some ways, and many researchers feel at the frontier that it's the most concerning one, and that is the risk of loss of control. So today, we actually don't know how to encode in a reliable way objectives that are safe to pursue in these AI systems as they get more and more capable, more and more clever, as they have access to a wider and wider action space. One of the risks is that they start to invent dangerously creative strategies to achieve their programmed objectives that cause a lot of harm. And so this is something that we're taking more and more seriously, that the whole community of AI safety and security folks is taking more and more seriously as well. And people at the Frontier Labs are quite concerned about that prospect.
You have also warned catastrophic national security risks. Could you give an example of how and in what specific ways this could pose a risk or a threat?
I think that both of the categories that Jeremy highlighted earlier are kind of the sources of risks like that. You could definitely imagine weaponized applications in various contexts. One that we're all concerned about in the relatively near term is the risk of persuasive power being deployed in the context of elections. And that both means large-scale persuasion. So you generate, a whole bunch of Twitter accounts or a whole bunch of Facebook accounts, and you can automatically get them to say things that support particular positions, but also the potential for actually superhuman persuasion on a one-to-one individual level. As these systems get more and more powerful, that increasingly becomes a risk. And then in the longer term, yeah, loss of control is a risk that's very much kind of global in scope. And there, it really doesn't matter who it is who's developing the technology. This is a risk that affects all of us, whether the person who's developing the system, because they lose control of it, ultimately it doesn't matter whether their intent was to use it for good or for harm. It just has this potential, catastrophic impact regardless. And this is something that has been highlighted as a concern by all the most highly cited AI researchers in the world, the three most highly cited ones, and two of the three founders of the field of deep learning, which underpins modern AI.
Interesting question. So one dimension of it is like, yes, we are plausibly, again, none of this is guaranteed. It's impossible to know for sure, but we're plausibly on a trajectory to build systems that are really good at persuading humans. We've actually seen this with GPT-4 with very impressive persuasive capabilities. It could convince human workers to solve those "Are you a robot?" tests, those CAPTCHA tests for it. And we've seen other kind of AI-powered chatbots demonstrate the capability to build long-term relationships with humans, even driving some human users in rare cases to the point of suicide when the relationship appears to fall apart or otherwise is compromised. So there are profound manipulation possibilities, kind of persuasion possibilities, in which humans end up de facto doing a lot of the work for AI systems that have other goals. But When you look at the prospect of loss of control, generally speaking, the scenarios that seem most plausible don't necessarily involve human beings doing a bunch of work, like in the Matrix or something, trying to power these systems. The reality is, AI systems are able to reason on computer clock time far faster than biological clock time. They're able to essentially operate unencumbered by a lot of the constraints that apply to human beings. And so it seems implausible that we would live in a situation where the best way an AI system could operate its environment is to somehow use wet, messy, slow human biology machines to support what it's doing. But all that is speculative. Ultimately, I mean, really the core here is there a risk of AI systems being weaponized? Absolutely. Is there a risk that that will create catastrophic outcomes? Absolutely. And there is a risk that, loss of control leads to systems ultimately going rogue and behaving in ways that we don't want them to, that may have catastrophic consequences. What exactly those look like is a lot trickier to hammer out. We've done a lot of work to kind of define scenarios that seem more or less plausible, but at the end of the day, we need to be prepared for a wide range of possibilities and approach this with an open mind that reflects the data, the evidence that we actually have pointing to this risk class.
Answer to what happens after AGI is going to be speculative, because this is potentially an event that doesn't have a historical parallel.
Is it possible the Skynet will appear in the future?
So I think that one of the issues with a lot of science fiction is, we got to keep in mind, science fiction is written to make stories entertaining, right? If Terminator wasn't entertaining, you and I wouldn't know about it because nobody would have watched it. And the reality is that what may happen in reality might not make for an entertaining movie. It might be anything on a spectrum of possibilities, from extremely weaponized persuasion that causes significant societal changes, to just these systems, maybe just building more power plants for themselves and kind of pushing humans out of various places. All of this is speculative, obviously. We're talking about, following the trends that do exist, but extrapolating them out into a potentiality into a possibility that is unlike anything we've ever experienced. But we got to keep in mind that while science fiction can maybe help us imagine concepts like, machines more powerful than humans, how that will actually work out in practice, it might just end up being mundane and boring in various ways. In which case, no one would have written any sci-fi about it. And there are all sorts of possibilities.
And it is somewhat challenging too, that this stuff makes us think of science fiction so much, right? Because we're used to, when we think about science fiction, we're used to, well, it's fiction, right? And so to some degree, we end up pattern matching to these ideas that make the issue set in some ways seem less significant than perhaps it may be, or more significant in other ways. One of the things to kind of keep in mind here too is although the idea of loss of control is indeed speculative, right? To some degree, there's a lot of evidence for it. The other thing that's speculative is the prospect that we might be able to build human level or more intelligent systems and maintain control of them. That itself seems like a very significant assumption. We've never actually built a system more intelligent than us. And so by default, you ought to maybe be approaching this with an open mind. And so, movies and things like that certainly help to broaden that spectrum, but they can also cause us to be in some ways over specific in terms of the possibilities that we anticipate.
Mm-hmm.
A great question. There is right now, it is not technologically understood how to do that reliably. And very quickly, there are kind of two related problems. The first problem is, how do you describe your goal to a machine in a way that you're sure that if it's really competent machine, it's going to carry out that goal correctly and you'll be happy with the results? It's like when you make a wish to a genie, right? The genie might interpret your wish in the way that you want, or it might interpret it in a different way. And then the second problem is, there's a deeper technological problem that even once you've written out what your goal is and you're perfectly happy with it, right now, we actually don't understand how to take a goal like that and make sure that an AI system is reliably pursuing that goal. So we need to solve both of those technological problems before we are able to do what you're proposing. And that's actually one of the things that we try to motivate in the action plan, is develop the scientific understanding we need to actually do this, which is what's required to assure safety.
And this concrete too. I mean, I think an example might help. So back in the day, when systems like GPT-3 and ChatGPT were first being built, right? They were built to be text autocomplete systems. So you would feed them a bit of text, and they would predict the text that would come next. Right. Now, the problem was sometimes they were a little too helpful, right? So you would write something like, in order to make a homemade bomb, just start by, and then it would autocomplete that and tell you how to make a homemade bomb, or at least do its best attempt to do that. So what people said was, okay, clearly text autocomplete is not the goal that we want here. We need some different objective. So they went, all right, we're going to get human beings to rate the outputs of these models. Surely if we do that, then we'll get a system that gives us what we want. The problem with that is, now what you've done is you've trained your system to optimize for human upvotes. Essentially, you've trained it to persuade human beings that its outputs are useful rather than necessarily produce true and useful outputs. And so this problem ends up being very sticky, very thorny, and there's no solution to it that anyone's been able to figure out.
Mm-hmm. Is that it is increasingly possible to do that. I would expect probably becomes possible in 5+ years. I mean, there are already Tesla Optimus is already something like that's fairly effective at like humanoid robot walking around. Figure recently released a demo of a robot that can make coffee for you. And there's a number of startups that are just actively working on this technology and actively raising investments. So it could, in principle, maybe it could occur within the current economic cycle. And certainly from the standpoint of AI technology, like, will the AI part of the technology be available within a short time horizon, or relatively short? I think that's fairly likely. We know a lot less about the mechanical aspects of the technology, so can't speak to that directly. Asking, would an AI build a body for itself? This is, again, takes us into that speculative territory. Once you have AGI, what's it going to do? Well, if we could predict that, it wouldn't be smarter than us, right? We would be smarter than it if we knew what it was going to do. But, we can certainly speculate. And if you think about how, what are the constraints on a system like this that it may want to break, given, any set of objectives? Jeremy talked about power seeking and how a system like this potentially, based on the limited stuff that we know and can extrapolate from today, could potentially act and seek to increase the amount of matter or energy under its control. You can imagine it, I don't know, building power plants and things like this. Would it build humanoid bodies for itself? My guess is probably not. But again, who knows?
Yeah.
That level, like, it's all speculation.
Yeah.
These recommendations, we go into a lot of detail in the action plan, but essentially there are 3 things that time now you need to do. One is, we need to stabilize the race that's currently going on between the labs, because that race is eroding safety and security. Number 2, we need to strengthen our capacity in terms of our ability to solve the technical problems that we talked about and actually have these systems under control, or have the ability to have these systems under control. And then number 3, once we've stabilized and we have the technical capacity to do so, then we should scale safely, both domestically and internationally, because at the end of the day, the goal is to get the benefits of this technology, which are massive and are already obvious.
Obviously would agree with Ed, as we co-wrote the report that he led. But yeah, I think that there are a couple of more details to double click on in that. The question is, what organizations are best equipped to support and fund the kind of research that's needed? Another is, what kind of research is actually needed? And here I think it's worth highlighting a couple of results that we've seen recently. First of all, we've learned that the evaluation techniques that we currently use to assess whether an AI model poses a risk are horribly flawed, right? So what we currently do, the cutting edge of AI today, if you want to evaluate an AI model, all you can really do is throw a bunch of prompts at it, try to prompt it in different ways to get it to behave in a dangerous way, to get it to reveal dangerous capabilities that it might have. Now, if you do that and you don't see the capability that you're looking for, you can't know whether that's because the capability didn't exist in the first place, whether the model just lacked that capability, or if it's just because your prompt wasn't good and you need to kind of re-engineer it and ask in a different way. And we keep finding over and over again that simple changes to the way that we prompt these systems can reveal capabilities we had no idea existed in the model. Even worse, what we're starting to find is AI models are now able to tell, in some cases, whether they are being evaluated and to adjust their responses accordingly. And that essentially undermines the foundational premise behind every cutting-edge AI model evaluation technique that exists. And so we're basically barreling away, or ahead rather, towards potentially very powerful systems, very powerful AI systems in the near future without a way of even auditing, even evaluating the capabilities that they have in a context where these models themselves might adapt their responses based on whether they're being tested or deployed in the real world. So it's a very big technical challenge, and it's something that we absolutely need to resolve in the near term if we're going to be able to scale safely.
China or Russia also developed the AI as a weapon or any hacking system. So do you believe that China and Russia also agree with that?
That's a great question. And this is, by the way, about a quarter of the action plan is focused on this question of how do you achieve international kind of coherence on this issue? How do you get an international regime to deal with these risks? A couple of pieces of context that I think are useful here. And the first is we have actually seen, especially in the aftermath of the UK AI Safety Summit, an emerging international consensus on the idea of catastrophic risks being on the table, including, and this has been really interesting to see, including the risk of loss of control. There's also recently a series of AI conferences held in many cases in China that featured prominent researchers from the West, Jeff Hinton, Yoshua Bengio, two of the founders of modern AI, where folks openly discuss the risk of loss of control in a way that would have been inconceivable just like 3 years ago. So those have been really, really positive developments. And we've also seen more and more evidence for the risk of loss of control surfacing. So that's going to help build international consensus. From a practical standpoint, there is also the question of the global AI supply chain. Of course, South Korea is a big player there. You have Samsung, you have SK Hynix, they're major players in high bandwidth memory and other areas located there. But there's also TSMC in Taiwan, of course, which is responsible for pumping out the world's most advanced semiconductor chips. So the ability to build frontier AI hardware, the hardware that can power these models is actually quite geographically concentrated. And that makes the supply chain easier to control so that we can establish at least an interim sort of stabilization regime internationally as we negotiate these treaties. So there's a lot of ingredients that we have here, and they're also kind of on-chip governance things you can do. You can put software and hardware on the actual AI hardware to control how it's being used and to make sure that it's being used consistently with international treaties if and when they exist. So there's a lot of promise there. We need to take a really technically informed look at this. That's what the action plan does. There are almost 400 citations there in terms of AI hardware papers and all kinds of stuff. So we need informed policymaking on this, but there are solutions to be found on this and other issues. Ed might be able to speak to this, but one important ingredient, every country has a different level of contribution to the international AI supply chain. South Korea is uniquely placed in at least two respects. One is it's got a lot of AI talent, folks who can actually make contributions at the frontier. Of course, Naver, one of the big leaders in AI internationally, they were one of the first companies to ever build a large language model relatively shortly after OpenAI. So there's that domestic capability in South Korea. There's also the hardware side. We spoke about SK Hynix and Samsung, other companies too. SK Telecom is involved in a lot of investments in companies like Anthropic. So I think there's a big role internationally to play for South Korea in establishing a global consensus around what risks actually do exist. And of course, you'll be hosting the next AI Safety Summit too. So that's a huge, huge venue to advance these causes and build that consensus. One of the crucial things is going to be making sure that everybody understands, has a technical understanding of loss of control risk in particular, because I think that's actually going to be a great way to build international consensus. Nobody wins if we lose control over these very powerful AI systems, no matter who builds them. So that's going to be a really nice way for nations to kind of share a common incentive to focus down this problem set. So I think that summit is already a big step forward. Participating in global controls regimes around AI hardware is going to be another important one.